Imagine you're in a spaceship and you keep accelerating. Faster and faster. You pass 1,000 kilometers per second, then 10,000, then 100,000. You keep firing your engines, pumping more and more energy into going faster. Logic says you should be able to keep accelerating forever, right? Just keep adding speed. But something impossible starts happening. The faster you go, the harder it becomes to go even faster. You're burning exponential amounts of fuel for tinier and tinier increases in speed. And then you approach 299,792 kilometers per second, the speed of light, and something breaks. No matter how much energy you pump in, you can't reach it. You get closer and closer. 99%, 99.9%, 99.99%, but you never actually get there. It's like trying to reach the end of infinity. The speed of light isn't just fast. It's a cosmic wall, an absolute barrier built into the fabric of reality itself. And the reason why will utterly destroy everything you think you understand about the universe. Because what Einstein discovered isn't just that nothing can go faster than light. It's that the speed of light is the speed of causality itself, the speed at which reality propagates. And understanding why this limit exists will collapse your mind. Let's start with what seems like a simple question. Why can't you just keep accelerating? In Newtonian physics, the physics you learned in school, there's no speed limit. If you have a force pushing you and nothing to slow you down, you just keep getting faster forever. Force equals mass times acceleration. Apply force, get acceleration, gain speed. Simple. In the Newtonian universe, if you had an infinitely powerful rocket engine, you could reach any speed you wanted. 10 times the speed of light. 1,000 times. 1,000,000 times. There's nothing in Newton's equations that says you can't. But Newton was wrong. Not completely wrong. His equations work beautifully for everyday speeds, but fundamentally incomplete. And the person who discovered why was Albert Einstein. In 1905, Einstein published his special theory of relativity. And buried in that theory is one of the most profound and disturbing truths about the universe ever uncovered. There is an absolute cosmic speed limit. And that limit is the speed of light. Nothing with mass can reach it. Nothing with mass can exceed it. And the reason has nothing to do with engineering limitations or the power of your rocket. It's written into the structure of space-time itself. Here's where we need to start building the explanation piece by piece. Because the answer isn't simple and it's not intuitive. Einstein's insight began with a puzzle about light. Physicists in the late 19th century had figured out that light is an electromagnetic wave, an oscillating disturbance in electric and magnetic fields. And James Clerk, Maxwell's equations predicted that these waves should travel at a specific speed, approximately 300,000 kilometers per second. But speed relative to what? When you say a sound wave travels at 343 meters per second, you mean relative to the air. When you say a water wave travels at a certain speed, you mean relative to the water. So what was light traveling relative to? The assumption was that there must be some medium, called the luminiferous ether, that permeated all of space. Light waves would be vibrations in this ether, and 300,000 kilometers per second would be the speed relative to the ether. This seemed reasonable, but when physicists tried to detect Earth's motion through the ether, they found nothing. The famous Michelson-Morley experiment in 1887 showed that light travels at the same speed in all directions, regardless of Earth's motion. This was bizarre. If Earth is moving through the ether, light should travel faster when going with Earth's motion and slower when going against it. Just like sound travels faster downwind than upwind. But it didn't. Light always traveled at the same speed. Einstein took this result seriously. He proposed something radical. What if the speed of light is actually the same for all observers, regardless of how they're moving? What if 300,000 kilometers per second isn't the speed of light, relative to some ether, but an absolute speed that everyone measures, no matter their velocity? This sounds impossible. If you're on a train moving at 100 kilometers per hour and you throw a ball forward at 50 kilometers per hour, someone standing on the platform sees the ball moving at 150 kilometers per hour. Speeds add. That's common sense. But Einstein said that for light, speeds don't add. If you're on a spaceship moving at half the speed of light and you shine a flashlight forward, you don't measure the light leaving at 1.5 times the speed of light. You measure it at exactly the speed of light. And someone watching your spaceship fly by also measures your flashlight beam at exactly the speed of light, not at 1.5 times. This is insane. It violates every intuition about motion. But Einstein realized that if this is true, if the speed of light is absolute, then something else has to give. And what gives is space and time themselves. For the speed of light to be the same for all observers, moving observers must experience time differently and measure distances differently than stationary observers. Time must slow down and space must contract. For moving objects in precisely the right way to make the speed of light come out the same for everyone. This is time dilation and length contraction, the most famous predictions of special relativity. If you're moving at high speed relative to me, I observe your clock ticking slower than mine. I observe your spaceship contracted in the direction of motion, squished shorter. These aren't optical illusions or measurement errors. Time actually passes more slowly for you, and space is actually compressed. And the mathematics works out such that when you measure the speed of light, despite your altered time and contracted space, you get the same answer I do, 299,792 kilometers per second. Now here's where the speed limit starts to emerge. Let's think about what happens as you accelerate toward the speed of light. From my perspective, watching you, several things happen. First, your clock slows down. The closer you get to the speed of light, the slower your time runs relative to mine. At 90% of the speed of light, your clock runs at about 44% the rate of mine. At 99%, it's down to about 14%. At 99.9%, it's about 4.5%. And as you approach 100% of the speed of light, your time approaches a complete stop relative to mine. At exactly the speed of light, your time would be frozen. No time would pass for you at all. Second, your mass increases, or more precisely, your relativistic mass. The resistance to further acceleration increases. At rest, you might have a mass of 1,000 kilograms. At 90% of the speed of light, your relativistic mass is about 2,300 kilograms. At 99%, it's about 7,100 kilograms. At 99.9%, it's about 22,400 kilograms. The pattern is clear. The closer you get to the speed of light, the more your relativistic mass grows. And at exactly the speed of light, your mass would become infinite. Think about what this means. To accelerate an object, you need to apply force. Force equals mass times acceleration. But if your mass is growing as you speed up, you need more and more force to produce the same acceleration. And as you approach the speed of light, as your mass approaches infinity, you'd need infinite force to accelerate you any further. No amount of rocket thrust, no amount of energy, could push you past the light speed barrier because your mass has become infinite. You'd need infinite energy to reach the speed of light, let alone exceed it. This is the cosmic speed limit, and it's not just a practical limitation. It's a fundamental feature of how the universe works. The speed of light isn't special, because photons are special particles that happen to go really fast. The speed of light is special because it's the conversion factor between space and time in the geometry of space-time. It's built into the structure of reality at the deepest level. Let me explain this more carefully. In Einstein's universe, space and time form a unified four-dimensional structure called space-time. Every event is a point in space-time, characterized by where and when it happens. The distance between events in space-time is called the space-time interval, and it mixes space and time in a specific way. The formula involves the spatial distance minus the speed of light times the time difference, all squared. The speed of light appears in this formula as a conversion factor, telling you how to trade off between space and time measurements. And here's the key. The space-time interval is invariant. Everyone agrees on it, regardless of their motion. Different observers moving at different velocities will disagree about the spatial distance between events and the time difference between events, but they'll all calculate the same space-time interval. This is the deepest principle of relativity. The geometry of space-time is the same for everyone, and the speed of light is the number that makes this work. It's the universal conversion rate between meters and seconds, between space and time. Now, in space-time, you're always moving. Even when you're sitting still in space, you're moving through time, aging, progressing into the future. You can think of your total velocity through space-time as being constant. But this velocity is divided between motion through space and motion through time. If you're sitting still in space, all your motion is through time. You're aging at the maximum rate, experiencing time normally. But the moment you start moving through space, you divert some of your space-time velocity away from the time direction and into the space directions. You're trading time motion for space motion. This is why time slows down when you move. You're using up some of your fixed space-time velocity budget on spatial motion, leaving less for temporal motion. And here's the crucial point. The maximum speed through space is the speed of light. If you were moving through space at the speed of light, you'd be using your entire space-time velocity for spatial motion. There'd be nothing left for motion through time. Time would stop. And you can't go faster than light, because you can't use more than 100% of your space-time velocity for spatial motion. There's no more to give. This is the deepest answer to why light speed is the limit. It's not that something physical stops you. It's that moving faster than light would be like pointing in a direction that doesn't exist. It's geometrically impossible in the same way that moving north of the North Pole is impossible. The speed of light is the maximum rate at which you can traverse space, because traversing space requires using your motion through space-time. And you only have so much to use before you've used it all. But there's more, and this is where things get truly mind-bending. The speed of light isn't just the speed limit for matter. It's the speed limit for causality, for cause and effect, for information, for any kind of influence whatsoever. Nothing can transmit information faster than light. No signal, no force, no effect can propagate faster than light. And the reason is deeply connected to the nature of time and simultaneity. In Newtonian physics, simultaneity is absolute. If two events happen at the same time, they happen at the same time for everyone, regardless of their motion. There's a universal present moment that all observers agree on. But Einstein showed this is false. Simultaneity is relative. Two events that are simultaneous in one reference frame are not simultaneous in another reference frame, moving at a different velocity. What you call now and what I call now are different if we're moving relative to each other. This leads to something shocking. If you could send information faster than light, you could send it into your own past, creating paradoxes. Here's how. Imagine you and I are moving apart at high speed. Our now slices through space-time at different angles because of our relative motion. If I send you a faster than light message, from my perspective it arrives at a specific time on your clock. But from your perspective, because our definitions of simultaneity are different, that message might arrive in your past. Before I send it from my perspective, you could then send a faster than light message back to me, and it might arrive in my past. Before I sent the original message, I could receive your reply before I sent my message. Cause and effect would break down. This is why the speed of light is the limit. It's not just a speed limit for motion. It's the speed limit for causality. If anything could go faster than light, the structure of cause and effect would collapse. You could have effects preceding their causes, information traveling backward in time, and logical paradoxes everywhere. The universe enforces the speed of light limit to preserve causality, to ensure that cause always precedes effect, that the past can influence the future but not vice versa. Let's talk about what this means for things that actually do travel at the speed of light. Photons. Light itself, electromagnetic radiation, travels at exactly the speed of light because photons have no mass. If you have no mass, special relativity allows you to travel at the speed of light. In fact, it requires you to travel at the speed of light. Photons are always moving at exactly 299,792 kilometers per second in vacuum. They can't go slower and they can't go faster. And from the photon's perspective, if it even makes sense to talk about a photon's perspective, no time passes. A photon emitted from a star a billion light years away reaches Earth instantly from its own point of view. It's born and absorbed in the same moment of its own experience. The entire history of the universe, from the photon's perspective, happens in a single frozen instant. This is what happens when you reach the speed of light. Time stops. Space contracts to zero in the direction of motion. The universe becomes a timeless, spaceless singularity. This is why massive objects can't reach the speed of light. You can't exist in a state where time doesn't pass and space doesn't exist. Only massless entities like photons can occupy that strange boundary condition. Now let's address the question that everyone asks. What if we found some trick? Some loophole? What if we could warp space, or use wormholes, or find some exotic matter that lets us cheat? The answer is subtle. General relativity, Einstein's theory of gravity, does allow for some exotic solutions where space itself can expand or contract faster than light, or where the topology of space could contain shortcuts like wormholes. These solutions don't violate special relativity because you're not moving through space faster than light. Space itself is doing something weird, and you're just going along for the ride. For example, during cosmic inflation right after the Big Bang, space expanded so fast that distant regions receded from each other faster than light. This doesn't violate relativity because the regions weren't moving through space faster than light. Space itself was expanding between them. Similarly, distant galaxies today are receding from us faster than light. Due to the expansion of space, we can never visit those galaxies, and we can't even receive light from them if they're far enough, because the space between us is growing faster than light can traverse it. But again, nothing is moving through space faster than light. The space is expanding. Wormholes, if they exist, would be shortcuts through the topology of space. You'd enter one mouth, travel through a tunnel in space-time, and exit from another mouth, potentially arriving at a distant location faster than light. Could get there through normal space, but you wouldn't be moving faster than light through the wormhole. You'd just be taking a shorter path. It's like cutting through a building instead of walking around it. Your speed might be the same, but you arrive sooner because the distance is shorter. However, and this is crucial, we have no evidence that wormholes exist in nature. We don't know how to create them. The mathematics of general relativity allows for them as solutions, but those solutions require exotic matter with negative energy density, something we've never seen and aren't sure can exist in the quantities needed. Even if wormholes are possible, they might be impossible to create or stabilize or traverse. The universe might have other protections against causality, violations that we haven't discovered yet. The same goes for other speculative ideas like warp drives, where you'd compress space in front of you and expand it behind you, riding a wave of space-time distortion. The Alcubierre drive is a mathematical solution to Einstein's equations that describes this, but it also requires exotic matter with negative energy density in huge quantities. It's not clear if such a thing is possible, and even if it is, there are problems with causality, with how you'd create and control the warp bubble, with the radiation you'd generate, and with a dozen other issues. It might be fundamentally impossible for reasons we don't yet fully understand. The point is that the speed of light limit is deeply woven into the causal structure of the universe. It's not just a rule about how fast things can move. It's a statement about how reality works, about how cause and effect propagate, about the relationship between space and time. Einstein uncovered that space and time are not separate absolute entities. They're aspects of a unified spacetime, and the geometry of spacetime has the speed of light built into it as a fundamental constant. Let me give you one more perspective on why the speed of light is what it is. The speed of light is related to fundamental properties of space itself, specifically to the electric permittivity and magnetic permeability of vacuum. These are numbers that describe how electric and magnetic fields behave in empty space, and the speed of light is exactly 1 divided by the square root of the product of these two numbers. This isn't a coincidence. Electromagnetic waves, light, are oscillating disturbances in electric and magnetic fields, and the speed at which those disturbances propagate depends on the properties of the space they're propagating through. In a deep sense, the speed of light is the speed at which changes in any field propagate through space. It's the speed of causality because it's the speed at which information can travel from one location to another via any interaction. Electromagnetic interactions propagate at the speed of light because photons, the carriers of the electromagnetic force, are massless. But in modern physics, we understand that all the fundamental forces are mediated by particles, called gauge bosons. And in theories where those particles are massless, the force propagates at the speed of light. Gravity also propagates at the speed of light. If the sun suddenly disappeared, Earth wouldn't instantly fly off in a straight line. we'd continue orbiting for about 8 minutes. The time it takes light to travel from the sun to Earth, because gravitational changes propagate at the speed of light. Einstein predicted gravitational waves, ripples in space-time that travel at the speed of light, and we've now detected them from colliding black holes billions of light years away. The gravitational signal traveled to us at exactly the speed of light, just as Einstein's equations predicted. So the speed of light is really the speed of all massless fields, the speed at which any kind of influence or information can propagate through spacetime. It's the universal speed limit because it's built into the metric structure of spacetime itself, and massive particles can't reach it because doing so would require infinite energy and would correspond to a state where time stops and space collapses, a state that's mathematically well-defined, but physically unreachable for anything with mass. What Einstein uncovered is that the universe has a maximum speed, and that speed is the same in all reference frames. And enforcing that consistency requires space and time to be flexible, relative, observer-dependent. The speed of light being the limit isn't an arbitrary rule imposed by some cosmic legislator. It's a consequence of the geometry of spacetime, of the relationship between space and time, of the need for causality to be preserved. The universe is structured such that there is a maximum rate at which anything can traverse space, and that rate is the speed of light. And once you understand this, once you really internalize it, it changes how you see everything. When you look up at the stars, you're seeing light that left those stars years, decades, centuries, millions of years ago. You're seeing the past because light takes time to travel, and nothing can bring that information to you faster. The night sky is a time machine, showing you the universe as it was, not as it is. When you use your phone, the radio signals carrying your data travel at the speed of light, which is why there's latency in satellite communications. When the James Webb Space Telescope looks at distant galaxies, it's seeing them as they were billions of years ago because the light has been traveling that long. The speed of light being finite and being the limit means the universe has structure, in time as well as space. It means causality is protected. It means the future can't influence the past. It means there's an order to events, a flow of information, a directionality to cause and effect. Without the speed of light limit, the universe would be a chaotic mess where effects could precede causes, and time would have no meaning. The limit isn't a restriction. It's a feature, a necessary component of a universe that makes sense, where physics is consistent, where we can have memories and make predictions, and live in a world governed by comprehensible laws. Einstein saw all of this in 1905, starting from the simple observation that the speed of light is the same for all observers. From that one principle, he derived time dilation, length contraction, the relativity of simultaneity, mass-energy equivalence, and the cosmic speed limit. He showed that space and time are not what we think they are, that the universe is weirder and more beautiful than common sense suggests, and that the speed of light is not just a speed. It's the fundamental conversion factor between space and time, the maximum rate of causality, the cosmic speed limit that structures all of reality. And that's what will collapse your mind. The realization that the speed of light, being the limit, isn't about rockets or particles or technology. It's about the nature of existence itself, about how space and time fit together, about the difference between past and future, about the flow of cause and effect. The speed of light is the speed at which reality itself propagates, the maximum rate at which anything can happen, the boundary between possible and impossible built into the deepest laws of physics. Einstein didn't just discover a speed limit. He discovered the architecture of spacetime, and the speed of light is the keystone holding it all together.